I'm Chris ADKIN, and in this session I'm going to talk to you about running Azure Arc enabled data services in production. A bit about me: I'm a Microsoft Data Platform Architect at Pure Storage. I've been working with SQL Server for 20 years and I've been involved in both the private and the public previews of Azure Arc enabled data services. On top of this, I spend an increasing amount of time in my day job working on Kubernetes. So I help produce a lot of the launch material and reference architecture documentation for Azure Arc enabled data services for who I work for. I've also worked with Microsoft in the past to produce Kubernetes documentation which has gone into their GitHub repos. Why this session? So there's a lot of content out there, a lot of people presenting stuff on Kubernetes, which is great. Present a deck, spin up some demos, it's all good stuff. But what about actually running a data platform on Kubernetes in production? Azure Arc enabled data services, it's only been generally available since the end of July, and that only really covers Azure Arc managed SQL Server instances. So if I'm going to talk to you guys about running stateful applications in production, you might be thinking, well, Chris, not many people are doing this, so the stuff you're about to tell us, where does it all come from? Okay, so where it comes from is from general good practice about running any kind of stateful application on Kubernetes. And just because Azure Arc managed data services is relatively new, that is not to say that there aren't already other people out there who are not running stateful applications on Kubernetes clusters. So they absolutely are, okay? And what I'm going to give you is a bunch of advice, hints, tips, and general best practice around that, which applies equally well to Azure Arc enabled data services. Before I do that, I need to make sure that we are all reading off the same page. So firstly, just so that we're clear on what Azure Arc enabled data services is, it's a database service or database as a service platform which runs on Kubernetes on practically any infrastructure. At the time of presenting this, you can either choose to deploy Azure Arc managed SQL Server instances or Postgres Postgres hyperscale server groups to what is known as a data services controller, which runs on top of your cluster. So the importance of the data services controller is that it extends the Azure control plane to wherever you're running Azure Arc enabled data services. Also, it facilitates the delivery of telemetry and logging data from your Kubernetes cluster up to Azure. We also need to know a few concepts and terms around Kubernetes. First off, you have worker nodes. I should mention that depending on what flavor of Kubernetes you're using, so if you're using OpenShift, some of the terminology is slightly different. In the world of Red Hat OpenShift, they refer to master nodes as control plane nodes and worker nodes as compute nodes. But the TLDR is that worker nodes and compute nodes are the same, and it's where your application actually runs. Next up, we have pods. So a pod is where your containers run. Containers run inside a pod. All the containers that run in the same pod share the exact same life cycle. They're always co-scheduled on the same worker or compute plane node. Next up, we have a couple of storage terms. You have persistent volumes, which map to your underlying storage platform, and then you have persistent volume claims, which is the means by which you consume storage from a volume. Then we have a kubelet, which is kind of the Kubernetes agent which runs on each worker or compute node. And in short, at a very, very high level, these terms, they give you enough to cover off the most basic Kubernetes cluster. Storage. So because Azure Arc enabled data services, it's effectively database as a service, there is a bit, not a massive amount, there's a bit that we need to know about storage, specifically the Kubernetes storage ecosystem. And it's kind of like a cake built up of layers. Okay, so you have a layer at the bottom, you have more layers, and then you have a topmost layer. So using that analogy, at the very bottommost layer of your cake, you have a storage device or platform, you have persistent volumes. These carve out volumes from your underlying storage platform. You have the means of consuming storage from your persistent volume, which is a persistent volume claim. And at the very top of our cake, we have the volume, which is almost like a Linux mount point. Okay, so your volume is the touch point for containers running inside your pods. Sizing. So there is a minimum worker node size, which is 8 gig of memory and 4 logical processors. You also need to consider that if you're using any kind of storage plugin, most vendors require that you have a minimum of 3 worker or compute nodes. This is for quorum purposes. So there'll be people watching this session who are familiar with failover clusters and the fact that you need a certain number of entities that can vote in order to establish quorum and in order to avoid split brain syndrome. Okay, the same thing applies with a lot of storage solutions for Kubernetes. So if you're using a storage solution for a particular vendor, what you should do is you should go for their documentation release notes, and you should understand the minimum number of worker nodes that requires, and in a lot of cases it's going to be 3 at the very least. Okay, usually your worker or compute plane nodes will be run on separate infrastructure from your master or control plane nodes. One exception to this is if you're deploying to bare metal. So if you're deploying to bare metal, you might actually find that you have master and worker nodes sharing the same underlying server hardware. And also Microsoft have some good documentation on the subject. A tale of 2 database engines. At the time of presenting this, putting this material together, although Microsoft are making noises about other databases and analytics platforms coming to Azure Arc enabled data services, you can deploy one of 2 things. So you've got Postgres Hyperscale, which is a scale-out data platform. It's based on technology from a company called Citus that Microsoft acquired. So if you're looking up the documentation, you see the term Citus, that's C-I-T-U-S. That's where it comes from. It comes from the company that Microsoft acquired in order to develop this technology. Then you have your more traditional scale-up database, which is Azure Arc Managed SQL Server instances. Your basic Postgres hyperscale architecture consists of a coordinator and a number of worker nodes per server group. So the thing that you actually deploy is, which is analogous to a SQL Server instance, is a server group. Okay, your workers are the things which do all the grunt work and heavy lifting. Your coordinator farms out work to your workers and aggregates the results that they return. You have one database per server group, and you partition tables across the workers. You can scale out your server groups. Obviously, you need enough space in terms of CPU and memory on your worker nodes. So this is an example of doing this with the AZ Data CLI. One thing I should mention is that this is being phased out in favour of the Azure CLI. So going forwards, you should use the Azure CLI for everything that you want to do via a CLI. Okay. So good question is, when you scale out a server group, where does your new worker go? And the answer is, it depends. Okay, so as I mentioned earlier on, that you need a data services controller to begin with. The act of deploying that, and also you might have Azure Arc Managed SQL Server instances on the same Kubernetes cluster. That might mean that the worker node that you want to scale your server group out to already contains or already has other pods running on it. Okay, one of the key algorithms that Kubernetes uses to schedule the execution of pods on worker nodes is a bin packing algorithm. And the reason I've got this little graphic which looks like Tetris is because that is more or less how the bin packing algorithm works. It works, so if you imagine Tetris and you've got bricks coming down from the bottom of the screen, and you have to rotate them and move them around so you can fit them in. Kubernetes sort of does something similar to that when it's using its bin packing algorithm to determine what pods run on what workers. There's some nuances that you need to be aware of. You can only have one database per server group. Storage classes cannot be changed post deployment. So a storage class is, it tells your application run on Kubernetes how it should consume storage. So typically what you usually have is you have one storage class per underlying storage platform. There's things out there which are a bit more nuanced. The solution that my company provides, you can have multiple of these per storage platform. But irrespective of what you're using, you need a storage class. Okay, so in the most basic configuration, you can use one storage class per SQL Server managed instance or Postgres hyperscale server group, or what you can do is you can have different storage classes, things such as say backups, logs, and data. The important point about Postgres hyperscale server groups is that once you've deployed your server group, you cannot change the storage classes at the moment unless you blow away your server group and then redeploy it with the storage classes that you want. The other option is to use what's called volume mounts. So, as I alluded to, because you've got a Kubernetes cluster, it's a shared resource. You might have different things running on it. You might have server groups. You might have SQL Server managed instances. you'll always have a data services controller. You cannot assume that just because you have a worker node that there's always resource capacity for you to expand your server group such that a new worker will land on that worker node. So one of the things that Microsoft's working on, and I can't give you any timescales around this or when this is going to come along, other than the fact that I'm reliably informed that this is happening, is the ability to influence pod placement. And the way you do this is you use what's called node selectors. So I've got an imaginary cluster here. It's got 4 worker nodes, arc worker node at 0, 1, 0, 2, 0, 3, 0, 4. What you can do is you can label these. So what we're going to do is we're going to label 2 of these with workload equals PGHS, Postgres Hyperscale, and then the other 2 with workload equals SQL Server MI, SQL Server Managed Instance. And what you'll be able to do is in a future release, once you've labelled your nodes up, you'll be able to say, I want to deploy a server group, but I only want to deploy it to worker nodes that are labelled with workload equals PGHS. Or I might want to say, I want to deploy a SQL Server Managed Instance, but I only want Kubernetes to schedule the pods associated with that instance on worker nodes labelled SQL MI. Okay, so keep an eye out for future releases, specifically the release notes, and once Microsoft give you the ability to influence server group, that's Postgres Hyperscale server group placement and SQL Server Managed Instance placement, you use this feature. Okay. Deploying to the public cloud. There's some nuances about deploying to the public cloud. So around worker node sizing, high availability, storage performance versus capacity, and overlay networks. If I was to make one point about deploying to the public cloud, it would be, don't automatically assume that by using the simplest option of deployment that what that gives you is something that's fit for production usage. Okay, so if I take AKS for example and the overlay network, so that's the network by which pods running on a cluster communicate. If you perform a basic deployment AKS, you get the most basic overlay network that's going, which isn't the best choice if the amount of communication between what's happening inside the cluster and outside the cluster is significant. So just be mindful of that. Okay. So the general idea of Kubernetes is to abstract away infrastructure. The guys that invented this, you've got Brendan Burns at Microsoft and Joe Bede at VMware. At the time, they worked for Google and they wanted to give people outside of Google a Google-like development experience. They had this thing running inside Google called Borg, and based off all the engineering know-how that went into that, they produced Kubernetes. Okay, so all your infrastructure is stuff that you should not need to worry about because Kubernetes abstracts that away. And to a large extent, it does a great job of doing that. However, and I'm going to bring up one of my favourite analogies, and that is the law of leaky abstractions by a guy called Joel Spolsky, who's one of the co-founders of Stack Overflow. And it basically states that as good as you try and make an abstraction layer, some of the details about the things it abstracts away will bleed through that abstraction layer. So what this means for you is, it means that although you don't have to become infrastructure experiencers, what it does mean is it means that there are 1 or 2 things that you need to be aware of. Okay. So the first thing I'm going to touch on in terms of things you need to be aware of with infrastructure is node sizing. Okay, so your worker nodes need to be a minimum size. Okay, but what you need to be aware of is that the more pods you have running on a worker node, okay, the more strain this puts on your kubelet. Okay. The other thing that you need to be aware of, so if we go back to the golden age of virtualization, so I'd say this is probably 8-10 years ago, there was always like this gold rush, mad dash for people to virtualize data centers. We can't have anything running on bare metal because that's evil. It all needs to be running on a virtualized platform. One of the golden rules was don't overcommit resources. So in the world of virtualization, this means don't have too many virtual machines running on your underlying physical hardware. In terms of Kubernetes, it means don't have too many pods running on your Kubernetes cluster worker nodes. Okay, so I mentioned kubelet overheads. So this information comes from Red Hat. The reason why Red Hat are important in the world of Kubernetes is because for a long time they have produced what many people to consider to be the only production grade distribution of Kubernetes for running on premises. It's not, I should say it's more of a platform than a distribution, but OpenShift container platform is based on Kubernetes. Okay. The reason why Red Hat are important is because Red Hat acquired a company called CoreOS, and CoreOS developed some of the key concepts, key components that Kubernetes uses. So you have an overlay network. They developed one called Flannel, which was one of the early and most popular overlay networks. They also developed etcd, which is a high performance key value store database, which runs on your master or control plane nodes for storing cluster state. So they know a hell of a lot about building platforms on Kubernetes which are fit for purpose for production environments. So what they're saying that if you have too many pods running on a worker or a compute plane node, this can result in slow pod scheduling, out of memory scenarios, exhausting the IP address pool, resource overcommitting leading to poor user application performance. Okay. The other thing to consider is one of the things that the kubelet needs to do is it needs to loop around all the pods running on the node, and the more pods there are, the longer this can take, and this can lead to workers or compute plane or compute nodes being in a state of not ready. Okay, and that leads to pod scheduling issues. Okay, so there's a kind of a balance to be. There's a balance here. You need worker nodes of a certain size, but if I'm trying to boil this down as simply as possible, rather than going for a few massive worker nodes, you're better off going for smaller worker nodes, but actually more of them. Okay, so as I mentioned, if you have too many pods running on a worker node, this can lead to nodes being in a state of not ready. So what to do? So the good people that run your public clouds, what they do is they actually provide some limits to protect you from yourself. So this is for Google Kubernetes Engine. One thing I shouldn't mention is that I'm not going to talk about AKS that much, and the reason I'm not going to talk about AKS is because, simply put, it makes zero sense deploying Azure Arc enabled data services to AKS. And the reason it makes zero sense is because you've already got things like Postgres Hyperscale and SQL Server managed instances without having to worry about a Kubernetes cluster. So AKS gives you those things natively. One of the ideas of Azure Arc enabled data services is to allow you to consume Azure data services on things which are not Azure. Therefore, I'm focusing on GKE and EKS for Google Cloud and AWS, and AKS not so much. Okay, so Google actually imposed some limits on the pods per node. Okay, with EKS on AWS, it's a bit more nuanced, so they've got the information in a repo. What I would probably do is, in the absence of any other compelling information, I would perhaps go with the limits which Google imposes, which is a maximum of 110 pods per node. And there's more. Another thing to consider is if you're deploying Azure Arc enabled data services to a public cloud, and I've said that's unlikely to be AKS in production because you get all your Azure data services without having to run a Kubernetes cluster, you still have to consider that there's a maximum of disk or volumes that can be attached to the virtual machines which make up your worker nodes. Okay, so this is another limit to consider. Something else to consider as well is, and this goes for all public cloud deployments, whether it's AWS, Google Cloud, Azure, what you tend to get is you tend to get better performance the bigger that the volume or the disk is that you use. Okay, so while this is good, it can mean that you're over provisioning for capacity you're not using, and obviously there's cost implications there as well. Your data controller. So I'll focus or zoom in slightly on Azure Arc managed SQL Server instances because they're GA and Postgres Hyperscale server groups are not. But with a Azure Arc managed SQL Server instance, what you can do is you can use availability groups. Okay, and that's fine. You can't do this for data controllers. So if you look at your data controller, two of the pods that it uses it's got a controlled database pod, and there's a control pod. They map to persistent volumes, and they map to persistent volume claims, or use persistent volume claims, I should say. Those in turn map to persistent volumes. Okay, so what you need to consider is if for example your data controller pods need to move from one worker node or one compute plane node to another, does the state associated with that pod move with it? And my best advice is, do not assume that if you're using any kind of storage plugin which comes for free with that platform, that you will automatically get this. So I can tell you that you don't get this with AKS. I can tell you don't get this with EKS. I can tell you that the story is a bit better with Google Cloud. So you need to test this. And if by downing a worker node, your data controller pods can't be rescheduled to run elsewhere because the state cannot follow those pods. You need to make provision for a storage plugin which caters for this. On top of this, if you're deploying to the public cloud, you also want to consider not only the fact that state needs to follow data controller pods around a cluster, but it needs to be able to follow data controller pods as they go from one availability zone to another. Okay, so this is kind of the picture. This illustrates what I'm talking about. Okay, so you've got a worker node, disaster strikes. Okay, what Kubernetes will do is it will do what it's built for at its most fundamental level. It's a pod scheduler. It will reschedule those pods to run on a different node. And the $64 million question is, does the state associated with those pods actually follow those pods from one worker to another? Okay. Another thing that you need to consider is volume expansion. Okay. So you've got two options here. Okay, so you can do the old school DBA thing, which isn't a bad thing to do, which is you can pre-provision storage to make sure you've got storage to allow for enough growth. The other thing that you can do is you can use a storage plugin which allows for volume expansion. One thing you need to be aware of is that in your storage class, you need the magic which this allow volume expansion true gives you to allow volumes to be expanded. And then once you've got that, what you can do is you can change the size of volumes and persistent volumes. Okay, and also there's some things out there which can do magic, like you can give them rules and they will automate all of that for you. Okay, so that wraps things up. Big special thanks to Microsoft for being the main sponsor. Thank you to all the people that support Data Platform Summit, so that's the organisers, the people that submit sessions, and most of all yourselves, because without there being an audience, this whole thing wouldn't really work. So that's me. I'm Chris Adkin. I hope I've given you some good food for thought. I'm available on Twitter. Just look me up. I'm Chris Adkin 8, uppercase C, uppercase A. The rest of it's lowercase. The 8's the double. Sorry, the 8's the digit 8. But any questions you've got which I'm unable to answer following this session, please feel free to reach out to me on Twitter.